Hey guys, this is Mitch with FinePoint CGI, and today we're going to talk about how to make a weighted randomizer of sorts for spawning objects and spawning items, or really technically getting anything that's random that you ever need on a weighted system. So we're going to go through the process of building our weighted system, our weighted group, and we are going to go through the process of setting it up. And then we are going to set up a small monster spawner using that weighted system, just to kind of show you how we can go about actually using this in a real world application. So that's what I have in store for you guys today. Let's go ahead and get started. Okay, so the first thing that we're going to talk about is what a weighted system is used for. So a weighted system allows you to group items based off of weight and spawn them at different intervals. So picture you have 3 items. So let me go ahead and make that for you here. So you have 3 items. You've got item group 1, item group 2, and item group 3 here, okay? And with a weighted system, what you can say is you can say this has a 50% chance of spawning. And you can say this one has a 25% chance of spawning. And then you can look at this one and say, okay, well, this one has a 10% chance of spawning. And then let's go ahead and give it another group real quick and say this one has another 10% chance of spawning, right? Now, the way a weighted system works is when you run your roll, right, you're rolling a dice almost, and you have a 50% chance that this box is going to come up. So when you have a group of 10 items, right, you should have this one being spawned 5 times, about this one being spawned about 2, maybe 2.5 times. We'll say in this case 3 times. This one should spawn about 1 time, and then this one should spawn about 1 time. And that's basically what we're going to be building. Is we're going to be building a system that allows us to randomly spawn items or monsters in a generic way. So now that we kind of have a basic idea of what we're building, let's go ahead and start building it. So I'm going to come into Godot here, and what we're going to do is we're going to go ahead and create a 3D scene, and I am going to go ahead and right click, attach a script, and we are going to go ahead and call it Monster Spawner, and we're going to make that a C# script, and we'll go ahead and click create. Now, Godot is going to go ahead and generate a CS proj and a solution for our project, which is great. And it's going to go ahead and bring up our IDE. Now, this class here is going to basically be a wrapper for our weighted group class. So what I'm going to do is I'm going to come over here and I'm going to click on the little new icon here, and I'm going to type all right, so the first thing we're going to do is we're going to go ahead and create our class here. So what I will do is I will say public class, and we'll call it weighted group. And we're going to make that of type T, okay? And what this does is it allows us to call our weighted group through calling a type, if that makes sense. So it'll make more sense in a minute, but I'll show you how that works. Then we're going to inherit from a dictionary. And we're going to make that of type T, comma, double. Okay, and the double is going to be the weight of our object. Now you'll see that the namespace dictionary doesn't exist, so that means that we have to use the correct using statement. So if we click on this guy, click on the little light bulb, we can use systems.collections.generic. And you can see that we have our dictionary of type T and a double. So the type T is going to be our class, and the double is going to be the weight of that object, the probability that that object is going to be spawned. We're going to say where T is a class. And what that's going to do is that's going to enforce a class object for our T. So one of the things that we don't want is we don't want people to be able to make a weighted group of binary data or of byte data or of some other generic type. We want it to be of a class, not of an object necessarily, okay? So that's what this is kind of doing, is it's enforcing that requirement, saying, hey, it needs to be of a class. It needs to be an item or a monster or something like that. Now, from here, we can go ahead and start building out our get item. So what we're going to say is public, and we need to return that item, right? So we need to return T because we need to return what item we're getting. So we'll say get item. And that T will be the same T that is here. So when we create our weighted group, it's going to set this as that object. So when we create a weighted group, so for instance, once, let's go ahead and return null here. Let me explain this in an easy way for you to understand here. So if I come over to my monster spawner, okay, and on ready, I want to create a weighted group, let's say, okay. So if I create a weighted group, I can say weighted group, and then I could do this bracket here, and I could say something like string, okay? And what that's going to do is that's going to set our weighted group as a string in here. So when we do our get item, it's going to return, right now it's returning null, but it's going to be using that type T as a string object, if that makes sense. And then of course we could say, you know, group is equal to a new weighted group string, like so, and that would basically initialize our object as we would expect. So that's kind of what this does, is it sets up these two types and it allows us to create our weighted group. Now, this is a weighted this is a type string, and it is a dictionary as well. So what's really cool is we could do something like weighted group string, and then we could do curly braces like this, and then to put objects in our dictionary, and we could say something like object 1 comma has a 50% chance of spawning, and that's valid C# here. So we could actually come in here and say, okay, object 1 has 50%, the next object has a 25% chance, and the other object has a 25% chance of spawning. And that would be how we'd initialize our dictionary for our object. Okay. Now, I know that seems confusing, but once we start getting into our weighted group and we start running our simulations and start getting things going, it'll make more sense. So if we come over to our weighted group and we go ahead and start building out our get item, let's come in here and say, okay, first we need to get our total weight. So we have our objects here. We have 50, 25, and 25. So our total weight's 100. But what if somebody makes a mistake? What if, you know, John down the street writes a 10 here instead? Well, it's no longer out of 100, it's out of 90. Well, 85. We need to be able to account for that. So what we're going to do is we're going to get our total weight, and then we are going to go ahead and make sure that our total weight is not 0 or less than 0, because what if somebody throws in a -10, right? And we don't want that necessarily, okay? So that's something else we have to keep in mind. So what we'll do is we'll come into our weighted group and we'll go ahead and get our total weight. So we'll say double total weight. So we'll say for each var item in values, I believe it's values, then, yep, that's correct. Okay, so for each item in values, and what values is it's the values of our dictionary. It's the objects that exist in our dictionary. So for each one of those, we are going to get the absolute value of it. So we'll say var ABS value is equal to math, and I don't think we have a math property here, so we'll go ahead and click on this and say using system dot ABS item, and then we'll say total weight plus equals our ABS value. And that will go ahead and give us our values here. Now you'll see that we do have an issue here where it says, hey, unassigned local value total weight. So I'm going to have to go ahead and set this to 0, and that'll solve that problem. So what that's going to do is we're getting our values, we're taking our values, and we're combining them into an absolute value here, and then we're adding it to our total weight. So we're lopping off any like weird parameters or anything like that. It's just going to get our total weight, okay? Now, we can do this in a way more efficient way, and I'll show you how to do that in a little bit, but just keep that in mind. So next, we need to make sure that our total weight is not 0. And the reason why is if our total weight is less than or equal to 0, then all of our code will break, right? Because we have to make sure that an object at least has some form of weight to it, right? So we'll say if our total weight is less than or equal to 0, then we're going to want to return. And we'll want to return null. We'll say, hey, it didn't work. We'll throw out a null. From here, we need to go ahead and roll our random number for our random number generator. So we'll say double roll is equal to a new random dot next double. And that'll pull back a double. And then we'll also grab our total. Okay. So we'll say double total is equal to 0 as well. And what that's going to do is this total value is basically our total value of our weights as we loop through them. So what we're going to do is we're going to loop through each individual weight and we're going to add them up. And once that total is over top of our roll number, then we know that it is the object we're looking for. So now we have to loop through our dictionary of objects, and we need to pull out who is our proper object, right? Now, we can do this a lot of different ways, but one of the easiest ways to do it is to basically take our dictionary, put it into a list, and then sort our list by descending. And what that's going to do is that's going to allow us to quickly and easily pull back our value without needing to do any funky stuff. And basically what we could do is we're just clumping all of our weights together so that it's largest to smallest. So that way we can say, if it's between these values, then it's this. If it's between these values, then it's that. And it gives us a really fast system. So this is going to be a little bit complicated, so bear with me, okay? So we're going to say for each key value pair t comma double, and we will say KVP for key value pair in, all right, so for each of one of our key value pairs in our dictionary, which is this, right? So this, but we want to sort our dictionary, okay? And you can't sort a dictionary without transferring it to something else, like a list or something like that. So we'll go ahead and sort it to a list. So we'll say to.toList. Like that. And you'll see that we have a little curly brace down here, or a little squiggly line down here. So we go ahead and click right here and use system.link to just kind of help us out here. Now from here, we need to go ahead and order it. So we'll say order by descending like that. And then we can go ahead and order it by our value, right? So we'll say v equals pointer value v dot value. And what that's going to do is basically we're taking our key value pair, we're pulling back our double here, our value, and we're ordering our key value pair as a list of objects, and we are sorting it by descending, if that makes sense. So now from here, we can go ahead and start trying to find our object. So we'll say total plus equals our key value pair dot value divided by our total weight. Okay. And the reason for that is when we are generating our numbers, we're generating our number from 0 to 1. So when you do this next double, you're actually generating out a number that is 0 to 1. And the thing about that is your values for your weight value is going to be something like 25 or like 50. So we want to divide it by our total weight. So that way we can make it from a 0 to 1 scale, if that makes sense. So for instance, if we were to say 50, right, divided by 100 is 0.5. So therefore we know that our total value is never above our total weight. So now from here, what we can do is we can go ahead and check if our roll value is less than or equal to our total. And then if it is, we're going to go ahead and return our key value pair dot key. And that's going to return our item. And then if we don't find our item here, somehow something got funky or got broken, instead of returning null, we should return our keys dot first or default, and that'll just pass back our first object or our defaulted object. So now from here, what we can do is we can actually use this, okay? This is literally all we need to do all of our generation. I mean, we've done it. We're basically done with the system. It's pretty simple. So what we'll do is we'll go into our monster spawner and we'll go ahead and start spawning our objects. So first things first, I'm going to make this into a global variable here, or at least a global variable for my class. So we'll go ahead and shove this up here. So that way it's just up here instead. And then what we're going to do is we're going to say, okay, when the project starts, let's go ahead and pull back our objects, right? So what we'll do is we'll go ahead and say, on process here, let me Control Shift P and toggle line comment. Let's get rid of that comment there. And on our process here, we're going to go ahead and randomly pull objects from memory, so then print them to console, okay? So what we'll do is we'll basically just print to the console objects that are going to spawn, okay? And we should probably keep track of almost like the percentages of those objects being spawned, or at least being printed, I should say. And what we can do is we can go ahead and just create a value up here. So we'll say private int max generations, and we'll set that to something like 100. I think 100 will be a good number. And then what we can do is we can say if, and we'll probably need a local one. So we'll just say private int current generation amount, and we'll make that equal to 0. And then we'll say if current generation amount is less than our max generation, then we're going to increment our current generation. So current generation amount plus plus, and that's going to go ahead and generate that and make it go increment by 1. And then what we'll do is we will go ahead and say gd.print group.get item. And what that's going to do is that's going to pull back a random item. So what we should see is we should see a about 100 items printing at our console at once. So if I come over here and I go into Godot here and I hit play, you'll see that we get a bunch of spawning of objects here, or a bunch of, I guess, randomized numbers here. So you can see we have 1, 1, 2, 3, 2, 2, 2, 1, 2, 2, 2, 3. And you can see that in general, we're getting a lot more 1s than we are of 2s and a lot more 2s than we are of 3s. And if we look at our object spawn rate, that seems to track with what we're trying to do. So that's awesome, right? So how can we see about what our spawn rate is, right? Because, you know, I could tell you that it's working and it's proper, but is it actually proper? Well, what we can do is we can go ahead and create a group of items and then tell it to generate and then determine what our variance is, okay? And I know that that's probably a little bit beyond what we normally talk about, but it allows us to basically see and test our code. It's kind of like doing a unit test almost of our code. So what we'll do is we'll say, okay, if generations, max generations, that's fine. We can go ahead and create ourselves a weighted group here. So we'll say weighted group of type T, because I don't know what the type is going to be. I mean, I do technically know what it is, but I'll stick with that. Results is equal to a new weighted group of type T. And you'll see that we do have a squiggly line here. So we'll go ahead and click on this, and we will make sure that that's a string, actually, because I don't think I can get away with doing a type T. So I'm going to do a type string. And then what we'll do is we'll go ahead and we'll say string item is equal to group dot get item. Okay. And that's going to return our item. And what we'll say is if results dot contains key item, then we'll go ahead and say results item plus plus, and that's going to go ahead and add to our item array, okay, to our item group here. And we'll go ahead and return. And then what we can do is we can go ahead and actually we might want to print this out. So we'll say, yeah, that'll be fine right here. So we'll go ahead and print this out. We will go ahead and say, instead of get item, we'll print result, which is fine. And this might not actually work because I have this. So I'll put this at the top like that, and that will allow it to print beforehand. And then what I'm going to do is I'm going to come in here and I'm going to say results.add item, comma 1. And what that's going to do is that's going to allow us to tally up all of our results. And then I go gd.print, and then I print my results. Now, what this is going to do is it's going to have us run through. It's going to fire off this little bit, and it's going to print our results. Now, this will run in our process, so we might not want to do this necessarily this way. So we could probably just go else if current generation amount is equal to max generations, then do this. So that way we only get it once, or at least once until the thing is done. But this is mainly for us just to test it. So let's go ahead and run that and see what it does. So we'll run this, and we'll let it run through. So you'll see we get our weighted group here. And actually, I think it's already done. I'm curious if it's getting into here. So let's see what this is doing real quick. So we'll run this. There we go. And we'll go ahead and run this real quick. All right, it's going to run through here. It's going to attempt to print our results. What's our results? It's empty. All right, and that's because I'm dumb. I need to print our item first, and that's why it's breaking. So we'll go ahead and do that real quick. So we'll run this and see what it does. There we go. We've got all of our objects, and then we're printing out our weighted group. Now, our weighted group, I'm just going to go ahead and put a breakpoint here instead of being fancy and trying to print it, because it looks like Godot is not going to want us to print it. So let's run this. Let's let it run through. And then once it hits this breakpoint, let's take a look at our results. Our results is empty. Well, that's not a good sign. Did I... Oh, because this is getting reset. That's my fault. I'm dumb. Okay. So we'll grab this, pull it out of our scope here. And that's because I'm setting it to a new group every time. So that's my fault. So let's run that again. Let's try it one more time. Knew it was something dumb that I was doing. So we'll run this. We'll take a look at our results. This, and then come down here to our non-public members and take a look at our results, which has 3 objects. And you'll see that on average, 0, which was object 1, ran 51 times. Object 3 ran 11 times, and object 2 ran 38 times. So if we look at our weighted group that we built right here, 50, 25, and 10. So that's pretty close to what we wanted. 51. If we were to have mathed this out a little bit better, that's about right. That's actually pretty close to correct. So this system works pretty well. So now if we wanted to, how could we use this to kind of, I don't know, spawn maybe some enemies or something like that, right? Well, what we could do is we could come in here and let's say we have a monster spawner, and we'll go ahead and just give it a couple position 2Ds like so. We'll just grab this one and we'll move this one over. Click on this guy, move it over here, Control C, Control V, or Control D, Control D, Control D, Control D, and Control D, and Control D. And we're going to spawn 6 monsters. And it's going to be at random, whichever 6 that we spawn. Okay? So what we can do is we can go to Scene, New Scene, create a 2D scene, and just call this a green monster, which will be simple enough. And then we'll go ahead and add in a child node, add in a sprite. Let's add in a sprite. And let's go ahead and pull down a sprite sheet. I'll go find one, and I'll be right back. All right, you'll see that I found a monster fantasy pack here. So it looks like we have 4 monsters that we can choose from. Now, I'm not going to go in and set up all these monsters, but I'll at least let them spawn for us. So go ahead and click download and say no thanks. Just take me to the downloads. Let's go ahead and pull down, I don't know, 1.3. Why not? Always pull down the newest one. And let's go ahead and pull this into our downloads like so. Let's go into our downloads and open up the objects. Let's go ahead and copy these guys. Go into our RES, open in File Manager. Let's create a folder and let's call it Monsters. And then let's go ahead and open it and paste those guys in. We're going to let Godot import it, which it imports really quite quickly. And then we'll go ahead and pop these guys open. Let's grab, I don't know, a couple of these guys. And let's change how their import is done. So import preset 2D pixel, re-import, and that'll go ahead and re-import them for pixel art. And then what we can do is we can go ahead and grab our flying eye. So let's see. Oh, I see. Okay, so we'll grab our sprite, we'll drag him in, and you'll see he's flying around and all upsetty. I think that's an attack sprite, actually. Did it not come with any other kind of sprites? Nope, it did not. Okay, so we'll go ahead and add this in. We'll go to the offset, go to the animation, and do H frames, and we'll do 4, it looks like. It's 2, 4, 6. It's 6 frames, so we'll set it to 6, and then we'll see how that looks. Perfect. So again, we're only using the first frame. We're not actually going to do any animation, but we're going to use the first frame for what we're using this for. And we'll call this the flying monster, actually. Very spooky. And then what we're going to do is we're going to save this as flyingmonster.tscn. We'll do the same thing. We're going to duplicate our flyingmonster.tscn, and we will call it our sword monster, I guess. .tscn. We'll open that guy up real quick. We're going to come into our sprite. We'll grab our attack sprite here, which is our little monster here. We'll go ahead and save that. We're going to go ahead and duplicate this again. So Control D, duplicate this as a, I believe, what's our other monster types that we have? We have a goblin and a mushroom. So we'll duplicate this. So Control D and put goblin. And then we'll Control duplicate it again, and we'll say mushroom. All right, so if we open up our goblin, we go to his sprite, and we go to the goblin, change his attack sprite to something like this. It looks like he has an additional few frames, maybe 11. Nope, maybe not. Let's reset him. Let's see what kind of frames he has. So he has a lot of frames. He has 2, 4, 6, 8, 10, 12. He has 12 frames, so we'll go ahead and say 12. And that will do it for him. And actually, I should probably rename these guys, shouldn't I? Goblin, Control S, change him to sword. and make sure he's good for monster. There we go. That'll work. And then we will do the last one, which is our mushroom. So let's open that guy up. Mushroom monster. Change this to mushroom monster. And then I'm going to click on his sprite, and I'm going to come up to our attack sprite, click on that. It looks like he probably also has 12 sprites, or maybe 11. Let me see. He has 11 sprites, so we'll go ahead and say 11, and that should work well for him. Now, granted, this doesn't really matter so much for us, but it's more just so that we can have a nice sprite for him to see. So now, with our monster spawner, if we go into our code, we can go ahead and say, and comment this out real quick. So Control-Shift-P, toggle line comment. So up here, instead of object 1, 2, and 3, what we'll do is we'll change that to our paths to the objects that we want to spawn, okay? So what we'll do is we'll say res:// and I believe, and I'm going to pull this open just a tiny bit, I believe we just called it flyingmonster.tscn, so we'll grab that. And then we have as well our goblin monster and our sword monster. So goblines, so goblin monster, flying monster, mushroom monster, and a sword monster. Now, if we don't want a huge amount of flying monsters, let's say 20. Goblins are everywhere, so we'll say something like maybe 30. Mushroom monsters are pretty rare. We'll only give them 10. And for sword, we'll say that they're pretty rare as well, and we'll say something like, we'll say 10. We'll put the mushroom monster at 5, let's say. Let's make it really rare. Now, the nice thing about our system is that even though this doesn't equal 100, the system's going to work. Okay? And what we'll do is we'll say for I is equal to 0, I is less than length, and for our length, we'll say get child count. And that should pull back the number of children. And then what we'll do is we'll say for each one of these guys, we'll get a random node. So we'll go ahead and get our items. So we'll say string monster path is equal to our group.get item, just like that. And then what we can do is we can say, okay, now that we have our monster path, we just instance it like normal. So we say packed scene, monster scene is equal to resource loader.load monster path as packed scene. That's going to pull back our scene, right? So we can instance our monsters. And then we'll say node 2D monster is equal to monster scene dot instance as a node 2D. And then what we can do is we can now add our object as a child of our child objects, of our little spawn location. So we'll say get child I dot add child monster, and then we can go ahead and just spawn it. So we'll say monster dot position is equal to a new vector 2, just so that we zero it out, so that we make sure that's in the correct location. So now if I open up Godot and I hit play, you will see that we get all of our 7 monsters. You can see that we have multiple goblins, 2 flying guys, and a skeleton. We didn't even get a mushroom because the mushroom spawns so rare. So if I close this and I rerun this, let's see what we get. We get 3 or 4 flying guys and 3 goblins. And you can see that it's different every single time we run it. And it's based off of our weight. So you can see how often we get our monsters versus our other guys, right? And of course, our goblin is so overpowered here that we're not getting too many skeletons or any of those other guys. The goblins and the flying guys are basically winning the constant spawning. And that's probably because goblin and flying monster literally make up most of our spawn, right? And that's okay, but it's just something to keep in mind. So yeah, I mean, that's basically how you create a very simple weighted object group. Okay, and I'm going to run through this one more time so that you guys kind of understand how these things work. So we created our class and we had it as generic type T. And the reason why we wanted the generic type T was so that we could put anything in there and it would handle it. We also wanted to inherit from a dictionary with a double as our second value, which would be our weight. And we make sure that our T object is a class. So that way it's not something that is a binary data or byte data or something crazy like that. We also added in a get item, which basically allowed us to get the absolute value of our item and get our total weight and combine all of our weight. And then we roll a random number and then we check our list against it or our dictionary against it. And we go ahead and check to see if the roll is less than or equal to the total. And that way we stop when we find our item and then we return our object. Now, like I said before, we can basically make it anything. If you really wanted to, you could make this a node2d object and it would handle that as well. So if you wanted a actual objects of monsters, not just a string, it could be that as well. Or if you wanted to, you could make it an item, right? You could say when the user opens up the chest, run get items and then drop in your item table and it would pull back the group or the item based off of its weight. So it would have a higher likelihood if it has a higher weight, more or less. So that is all I have for you guys today. So if you like this video, go ahead and hit that like button. Hey, if you dislike this video, go ahead and hit that dislike button because I am here to make content for you guys. This video was a viewer suggested video, as with all of my videos on this channel. So if you have a suggestion, please leave it in the comments below and I'll be more than happy to try to get to it. I have recently started looking into Fmod because I know some people have been asking me to look at that, and I do still owe you guys a Nakama tutorial and a Silent Wolf tutorial and a bunch of other tutorials. And I have a Trello board, link is in the description, that has all of the tutorials that are on my list currently. So if you don't see it in there, go ahead and suggest it. I'd be more than happy to take a look at it. And hey, if you guys have any questions about this or comments, leave them in the comments below or jump on my Discord. Link is in the description. And any of the guys there will definitely help you out and would be more than happy to talk to you. But that is all I have for you guys today. So thank you so much again for watching. And I will see you all next time. Thanks.